All right. Good evening, ladies and gentlemen, and welcome to this live session on a Saturday. And let me open my. Okay. So today we are going to discuss a very interesting topic, which is called as because in last couple of sessions back, somebody was asking what is this confidence intervals and how they are calculated. What is the practical application of this? So today we are going to decode confidence interval. What is confidence? What is confidence interval? What is confidence level? How they are calculated? What is the practical application in our day-to-day life, in our processes? That will be today's discussion. Okay. Now today's topic, as we most of us know this, Saturdays generally we cover a little advanced topic. Okay. Of course, all the topics which we cover are important for your green belt and a black belt journey. Okay. And all of them are important and they are in your curriculum itself. All right. So we are not going outside of the curriculum. So whatever is there for green and black belt, we are covering. So generally, in black, see, there is no hard and fast rule for that, but generally what happens is there are new people coming in on Sunday. So Monday generally we cover green belt level stuff, and Saturday generally we cover the black belt level stuff. Okay, so this is just a broad level understanding of it. Okay, so today's topic is about confidence interval. Okay, so I have a small PPT to share. So first start from the basics so that everybody will be on the same page. So let me share my screen first with you. And then I will be sharing this with you as well in the masterclass archive. Okay. Here we go. So this is the confidence interval. So first we'll understand what is confidence interval, and then we will understand what are the practical applications, etc. Okay, so is my voice audible and is my screen visible? Just give me a quick yes in the chat box for everybody, because my second screen is not yet started by my team. Team is working on that. Okay, yes, thank you very much for the confirmation. Chalo, let's work. Let's start with confidence interval. Okay. All right. Now, let's touch upon some of the basics. The first one is statistics. What is statistics? So I have made it very simple definition of statistics. Statistics is a science which converts data into information. Okay, because data does not have any meaning to us. Our brain cannot comprehend the data. So statistics, what it does, with the help of some graphical and statistical tools, it converts the data into some meaningful information which can be used for decision making. For example, let's say I want to check the sales of the year. Okay, so we will fetch the data from, let's say, January to till this month of September, right? So it will be weekly or daily or monthly, whatever it is there, right? So if I'm given a Excel sheet of it, my brain will not be able to comprehend anything out of it. But instead of that, if I draw a trend chart, whether my sale has gone up or gone down or has some fluctuation, so I can make some sense out of it. And that information will be important for me to take some important decisions. So statistics will convert data into information. Yes. Now, when it comes to statistics, there are two important parts. One is called descriptive statistics, another is called inferential statistics. What is descriptive? Descriptive is nothing but about the sample of the data. For example, everybody is aware of the theory of sample and the population. Just give me yes in the chat box, which in our live sessions also we discussed multiple times. Just give me yes. Sample population, everybody knows, very simple, right? In quality also, we take the sample, we check the sample, and then whatever is conclusion is applicable for the entire population, correct? Sample and population. Anybody does not know sample and population theory, please let me know in the chat. If you don't know, I can explain you. It's not like, everybody's saying yes, you have to say yes. Aisa nahi hai. This, right? Correct. Yes, exactly. So we take, because practically speaking, we cannot inspect 100% all the time. Correct? So we cannot inspect 100% all the time. So we take some sample, right? Yeah, Sandeep ji, for you, just a simple example. When we cook rice, okay, when we cook rice in the pressure cooker, or let's say that utensil or the pot, right? So whether that rice is cooked or not, how do we come to know? We just take out a small bit of it, we crush it, right? So that we can sense whether it is. So that is a small sample we have taken from the entire pot of rice or that cooker. So that is a sample taken, and that sample is tested with our crushing test. We can say, call it as a crushing test. Okay. If it is very smoothly pasted kind of a thing, then it is cooked. If it is not, then it still requires some more steam. Correct? So this is a simple example of a sample and a population, because we cannot check the entire population practically. It will not be practically possible. It will not be economically viable. And it is not even required as well. Because what happens is, if the processes are standardized, and most of us have a standardized process, right? So if the processes are standardized, so if after a certain interval, if we keep on taking some samples and check it, we can assume that it is, applicable to most of the population. When I say population, I mean the entire set of data. When I say sample, exactly, it is a representation of the population. For example, let's say there are 25 people in the room right now. Assume that, okay? And Sparran and Gavin has 10,000 students, right? So this is a sample of SNG community. This is not the entire community. It's a small sample of the SNG community. Another example, when we are not well, we go for the blood checking, right? So now in our body, in a human body, there is approximately 5 to 6 liters of blood. Now, when we go to the pathology lab, that lab technician or that person does not take the entire blood out of the body, right? For the checking purpose. They take a small bit of it, and that's a sample of it. From that sample, okay, then the physician will basically come to know what kinds of infections are there inside the entire body. Okay, so this is what the sample and the population theory is all about. Clear, everybody? Just give me yes in the chat. Sandeep ji, are you clear? Very simple. Sample population. Super clear. Yeah. SC is for super clear, by the way. It's not Supreme Court. Very good. Super. Now, similarly, I give this simple example of a T20 cricket match. Okay. Because right now, the Asia Cup is also going on, right? So tomorrow we have India-Pakistan encounter. So I have recorded, right? Yeah. Good, good, good. See, guys, if you found this meeting is not getting recorded, please remind me in the chat, okay? Because so that we can, record it and we can observe it, we can watch it later as well. Anyway, so when the T20 match happens, let's say 3 overs. Imagine 3 overs and 25 runs and 1 wicket. Now, this is a scoreboard. This is a sample of total 20 overs. And in the same match, we have a predicted score. Correct? Predicted score that this team will reach around 200 runs or maybe around 210 runs. Yes, that predicted score is called as inferential statistics. And this sample score, which is the exact score, whatever has happened, it is a small piece of it. 3 over is a small subset of 20 overs. So that is called as descriptive statistics. So descriptive is about the sample. Okay. And from that sample, we predict the behavior of the population. In this case, population is 20 overs. Are you clear? So description is the sample of 3 overs. From that, we have predicted the predicted score. That is called the inferential statistics. Everybody's clear about this? Just give me yes in the chat. Super clear? Just give me yes. In the same cricket match, if you see, in the beginning of the cricket match, they show us the statistic. Okay. India and Pakistan, let's say they played 50 matches of T20. India won 35 matches, Pakistan won 15 matches, and there is a win prediction as well. That is inferential statistics. So what has happened in the past is a descriptive statistics, and the prediction about the future, about the population, is inferential statistics. Okay. Now, when it comes to descriptive statistics, there are two parts. Of course, we are not going to cover this part. What are the two parts? Central tendency and dispersion. Let me just quickly draw this over here. See, when we see the normal distribution like this, the first part which we cover is central tendency. Central tendency is nothing but where is the center of the data. Okay. Generally, we consider average, which is the mean. Average or mean is the center of the data. Of course, there is mode and median also are there. So mean, mode and median are basically the measure of the central tendency of the data. So whatever data we collect, we take the average. For example, in our schools also, we take average marks, right? So we take all the marks of the subjects and then we take the average. That will be the average percentage. Are you understanding? So let's say there are 10 subjects. So we add all the 10 subjects marks divided by 10, whatever comes there, that is the average percentage, average marks, right? So this indicator defines, the lowest, highest, whatever is there, what is the average, what is the center of the data point. So average remains the center, mode and median also are the two indicators, okay? Apart from that, there is second indicator, that what is the dispersion of the data. What is dispersion? Dispersion measures the variation of the data, variability. Okay. What is the lowest score of the data? What is the highest score of the, of the student, right? So that is called the variation of the data, which is nothing but dispersion. That can be shown as range, variance, and standard deviation. Okay. So there is one is central tendency, other one is called dispersion. So these are the two major parameters we measure in the descriptive statistic. Whenever we collect the data, we check where is the center and where is the dispersion, because both are very important for our further calculation, for our process capability, etc., etc., etc. Clear, everybody? Just briefly, we are not taking care of this part today. We are going to talk about inferential statistic today. Okay, are you clear with descriptive statistic? Just give me yes in the chat box. Simple calculation के लिए, let's say we check the heights of the people sitting right now in the room. Everybody, type their heights. Okay, now let's not do it right now. And after that, we will collect the data and take the average. That is the central tendency. Okay, and from the same data, we calculate who is the who is the shortest person in the room and who is the tallest person in the room. That is the one of the measure of the dispersion. That is called the range. Okay, so this way we can calculate how the data basically is is behaving, central tendency as well as dispersion wise. Now we are interested today is about the inferential statistics. Okay, so in black belt level we go deeper into inferential statistics. So let me write down what are the various inferential statistics we have here. You can just list it down. So hypothesis testing is an inferential statistic. Okay. Regression is an inferential statistics. Design of experiment, DOE, is an inferential statistic. Process capability, I'm just writing below. You can just write this down. Process capability analysis. What is process capability? CP, CPK, sigma level, all these are inferential statistic. And then we have confidence interval. That is also inferential statistics, which we are going to cover today. So hypothesis testing, regression, DOE, process capability analysis, confidence interval, these are various types of inferential statistics we cover in our green and black belt levels. Clear? Just note this down. So Of course, we are not covering hypothesis, we are not covering regression, we are not covering DOE today, we are not covering process capability today, but we are covering confidence interval today. Clear, everybody, where we are coming? Yeah, DOE is called as design of experiment. Just make a note of it. It is a very important part of black belt. Black belt may we have DOE. In master black belt, we have advanced DOE. Okay. Very, very advanced tool where with the help of these experiments, we can play around multiple factors at a time to optimize our process output. Okay. And by the way, it can be done not only in manufacturing, but it can be done in service sector as well. Okay. हाँ, आपके ब्लैक बेल्ट में अश्विनी जी you will find DOE का पूरा डिटेल. Okay. So once you go in the black belt level, there is a complete segment on the DOE. If you want to check quick DOE, black belt hackathon, third day. Okay, black belt hackathon, the third day, complete day is 3 hours. We cover complete DOE. Okay, so you can just check out on that as well. So just for your information. Okay. Anyway, so let's move to our. So descriptive inferential ho gaya, right? Fantastic. Chalo. So let's talk about now. There are two types of estimations. All right. Now you would have seen the astrologers. Now understand this. Huh? Now when I say estimation, I'm talking about kind of a prediction kind of thing. Okay. Estimation about the behavior of the population. Now there are two types of estimation. One is point and another is range. Let me give you an example. When let's say when we go to an astrologer or a tarot reader or an astrologer or whatever, now they will say that let's say somebody wants to get married, okay, and you are curious when is the best time for me to get married, okay, or when is the best time for me to start my business, or when is the best time to whatever it is, if you believe in that. Now those people will tell it will be between 27th to 28th year of your age. They will never say that it will be on 27th, after your 27th birthday, it will be 152nd day. No. They will never say like this because it will become a point estimate. But they will give a range. It will happen between this and this. Why? Because there are so many other parameters and planetary movements and all those things will come to play. So they will give you a range of the date that it will happen in around this month or around this year or around this, these weeks will be there, right? So they always will give the range. For example, what is point estimate? Let's give this example. If we take the same, let's continue the same example of the heights. If we take the height of all the people sitting in the room and the average is coming to, let's say, 158 centimeter. I'm just giving you example, okay? Can we say that if we take all the population of SNG community members, the height will come exactly 158 centimeter, the average. Can we say like that? Just give me yes or no in the chat box. Can we say yes or no in the chat box? Yes. Okay, everybody's saying no, correct? Can we say with confidence 100% ki, so average of the population will be 158? No, right? We can't tell that. It will give us some kind of a, idea, but we cannot confidently say that it will be. So whenever we collect the sample, okay, we always estimate not the point, but a range, okay? And that is called as range estimate or interval estimate, okay? What is interval estimate? Interval estimate is an estimate which provides the range of values likely to contain the population. See, as I said, this is a sample Yeah, no problem, Sunilji, no problem. You can check the recording, yeah? So this is a sample and this is the population. Now, when we are checking the X bar, which is the average of this, we can say that the population X bar will be somewhere between this. Population average is denoted by mu. You can just make a note of this. Sample average is denoted by X bar. Population average is denoted by mu. This is called mu, mu. Okay. So we give the range that if X bar is here, okay, the population ka average will be between somewhere between this point to this point. It will be somewhere in between these two. That we can do that, and that will be more, there is more likelihood that we can get our average of the population within this range. There are more likelihood of that rather than 158, only 1 point estimate. Okay. So this is called as interval estimate, which is very popularly practiced by the statisticians as well. That's what we are going to learn today. And this is called as confidence interval. Now, what is confidence? Try to understand this. What is confidence? Try to understand this. Okay. For example, I have 100 pieces of the products. Okay. Out of which, now you have to give me the answer between high, medium, and low. Okay. High, medium, and low. If I check, let's take example of it. Let's say mobile phone, 100 mobile phones I have, and I'm testing the quality of the mobile phone. I'm just giving you a very simple example. I have tested only one mobile phone out of 100. What will be my confidence about the 100? Will it be high, medium, or low? H, M, or L? Type in the chat box. Just type H, M, or L in the chat box. Everybody. Low. Yeah, H is high, M is medium, L is low. You have to give me one option out of it. If out of 100, if I test 1, what will be my confidence? Okay, low, very good. Out of 100, if I test, let's say 20 samples. This is a sample I've taken. Will it be high, medium, or low? My confidence about my, see, I cannot test all the 100. See, we have to go practically as well. So it will be between medium, around medium, right? What if out of 100, I test 50, almost 50, almost 1 out of 2 I've tested. What will be my confidence on my population behavior? That will be much higher, right? Very good. So what is indication here? More the sample size, more will be the confidence. Are you understanding? More the sample size, more will be confidence. Are you understanding? One scenario clear? More the sample size, more is my confidence. Correct? Now, second will be randomness. For example, now we as a country, India, we have a huge landmass. We are a huge country, the 5th or 6th largest country in the world. We have 29 to 30 states, and most of the states are bigger than most of the countries. Are you understanding? Now imagine I have to take a sample of India. All right, just try to understand this. But I only take sample from Kerala and Tamil Nadu. What will be my confidence? Only if I take sample from Kerala and Tamil Nadu. Low, high, or medium? It will be low. Correct? Right? If I take sample from all the states, what will be my confidence? That will be high. So it is also taking care of the randomness of the data, covering the entire mass of the of the population. So it is about the sample size. It is about the randomness. It is about collecting the data from all the sides of the population. Clear? So this way, when we collect the data, okay, how many of you are from the quality? Just type me in the chat box. Quality में कौन कौन है? Quality control, quality assurance. Anybody doing testing, quality testing? Just give me in the chat box. Anybody in the room? Okay. Very good, very good. So, how do you calculate your sample size when you collect your quality, when you check your quality? Do you have a fixed sample size which is defined? Just give me yes or no in the chat box. Or is it randomly you decide? You go and one day you have a good mood, so you can take more samples. Other day, you are not in a good mood, so you can test less samples. ऐसा होता है क्या? No, we have a formula which basically gives us the idea, and that formula is derived after taking care of all these factors which I just spoke: the sample size, the randomness of it, the standard error of everything. So everything is taken care of, and uh, so our confidence will be on the higher side. Now, when we check that, yes, very good. So fixed number of samples. So that number is fixed. So one of the formula is called as square root of n. This is also one of the popular formula. For example, if I have 100 pieces, I will take square root of it, which is 10. So I will test 10 samples from that 100 pieces, and that will be my sample size. This is one of the strategy. Okay. Similarly, there are various strategies according to industries and according to the organizations. Okay. Now, once we collect the data accordingly, we can set our confidence level. Confidence is what? Our confidence about predicting about the population. Confidence about our population prediction, that can be set at 95%. How much? 95%. Okay. So is it fixed number? The answer is mostly yes. Okay. So statistician, I also recommend to my clients, do not play with this confidence level. It generally set at 95%. We cannot be 100% confident unless and until we check all the 100% population. We cannot be. See, when can we be 100% confident? Only and only when we check all the 100% of the population pieces or the data. Then only we can be 100% confident. Otherwise, no. So even though we use the statistical formulae, the sampling strategies and formula, etc., we can set our confidence level at 95%. Now, when we say 95%, there is a small error of making the judgment, and that is the reason basically we go for the interval estimate. Okay, we don't give a point estimate, we give a range of the data point, and that is what we are going to learn today. How this estimate is calculated. So first, let's do one exercise here. I'm just giving you a file, Minitab file here. First, we will do this exercise, and then we will proceed further. Okay. So same file है, अपना regular file है, वो जो process chocolate weight वाला file. Okay. वही file मैं दे रहा हूं आपको एक बार फिर से. Can you just open this file quickly? Now the people with Minitab, if you're not traveling, etc., you can easily open this. Okay. You have laptop with Minitab. Otherwise, just observe this. Okay. Just small exercise we are going to do. It will just take couple of minutes time. Okay. Even if you don't have Minitab right now, it's okay. जिनके पास है वो ओपन करो. Once you have opened it, let me know, please. Okay. Let me also open this file. Our regular chocolate weight wala file open karo. Just give me yes once it is open, or done once it is open. Okay. Super. Have you access the Minitab from our system. If, see, it will not support mobile phone, you require a laptop. It will not support the laptop which does not have Minitab installed. It will not support any other, what you can say, version of Minitab. Okay, if version difference is there, it will not support. It's not installed. Okay, okay. So what you can do is you can just send a message on our mentor number now, and mentor will guide you. You know, mentor number से आप message डाल दीजिए, they will guide you. Okay. Yes, 2 minute के exercise आप देख लो, and then we will check that. Okay. Yeah. Done. Chalo. So once it is opened, this is just a weight of the chocolate. All right. Now what we'll do, we will just quickly do a basic statistical analysis. Okay. How we can do that? Go to stat, go to basic statistics, and go to graphical summary. So we are doing graphical and statistical, both analysis in one shot. So stat, basic statistic, graphical summary. Can you just do this quickly? Stat, basic statistic, graphical summary. Click on that. Just this window will appear. Just select chocolate weight and click on OK. And you will get this. Okay. So everybody got it? Just give me yes in the chat box. So this is descriptive statistic, which is nothing but mean, mode, median, variance, standard deviation, all those things. And here is inferential statistic. हाँ, मैं फिर से बताता हूं. Go to stat. So follow this path. Go to stat, basic statistic, which is the first option. In that, there is something called graphical summary. Okay, open that. There will be a window will get opened. In that first box, just double click on chocolate weight. It will get selected. Just click on OK. That's it. So go to stat, which is there here. You can see here stat. Once you click on that, it will come to the first option is basic statistics. In basic statistics, third option is graphical summary. Yeah, Gauravji, if you are done, just give me a confirmation. Correct. Yeah, just follow this and quickly let me know if you got it. Okay. And उसमें box आएगा, just select our chocolate weight column and click on OK. So you will get this graph. Everybody got it? Just give me yes in the chat box. Okay, so today we are not covering descriptive statistic. We are covering inferential statistic, which is chocolate box and OK. Yes, perfect. Box में chocolate को select करो and click on OK. So I'm giving you a chocolate box, virtual chocolate box. Okay, so here what is basically shown here is, understand this, 95% confidence interval of mean. What does it mean? See, actual mean of the sample. See, this is the sample mean, which is nothing but 42.106, which is actual mean of the sample. So what we are saying, the population mean with 95% confidence, the population mean will lie between 41.808 and 42.403. Okay. Similarly, the median of the data set is 42.1. Okay, median. What is median? If I arrange the data from lowest to highest, what is the central value of that data set? It's called as median. Okay, so median is 42.1. So what is the 95% confidence interval of median? With 95% confidence, the median of the population will lie between 41.58 and 43.32. And same goes with standard deviation. Standard deviation is 1.645 for the sample. What we are saying is, with 95% confidence, the standard deviation of the population will be between 1.46 to 1.885. Clear? Now, we are going to decode the formula to calculate this 95% confidence interval. Clear hai? Just give me yes, and then we'll see the practical applicability of it. Just give me yes if you got this. See, again, we don't have to calculate it manually, but as a Lean Six Sigma practitioner, we should be able to understand it. Okay? So Sandeep ji, let's try to understand this. You understood the sample and the population, right? Sample and the population you understood? Correct? Let's focus here. Let's focus on this part only. Okay? Let's focus on this part. Okay? Now, so this is the data. This is the histogram from the sample we have selected. Okay? From the data which we put in that. It's a sample of around 120 data set. Okay. Now, from this sample, the mean is calculated. This is the mean, which is 42.106. This is the mean of the sample. Sample mean. Okay. Now, can we say that the population mean also will be 42.106? No, we can't do that, right? That's why inferential statistics comes into picture. What statisticians say? We can say that with 95% confidence, that's what we say, interval prediction or interval estimate. Okay, this is called interval estimate. With 95% confidence, we are saying that the mean of the population, this is just a sample chocolates. Population could be entire day's production or entire month's production. Okay, that will be a population. So what we are saying, if we collect this data, let's say complete day's production, the mean of that, if we calculate the mean, that will be between 41.808 and 42.40. So this, how they are calculating this is what we are going to decode today. Clear? We are predicting the behavior of the population with that range. Got it? Just give me yes in the chat box. So briefly, conceptually understood, so that we can decode the formula behind it. Got it? Just give me yes. Very good, super. चलो अभी इसका formula decode करते हैं. Let me go back to my. Now everybody need to write down this formula. So confidence level मैंने दिखा दिया, confidence interval मैंने दिखा दिया, तो ये formula आप लिख लो. So formula for CI is X bar plus and minus critical Z value. Critical Z value क्या है मैंने नीचे दिया हुआ है. Into, in bracket, standard deviation is sigma divided by square root of n. N is equal to number of data points, sample size. Okay. So यहाँ पे आप लिख लीजिए. What is that? X bar is equal to mean. Z will be the critical Z value, which is a fixed value. Actually, fixed है. Value. Okay. Sigma is standard deviation. And n is equal to number of data or sample size. Number of data points. And understand this. Critical Z value, if the confidence level is 90%, it will be 1.45645. But as I said, we consider confidence level at 95% only. So critical Z value you have to consider 1.96, which is the standard, which is the constant. Clear, everybody? Have you taken this Either a screenshot or have you taken down this? Just give me yes in the chat. Done? Done, done, done. Very good, very good, very good. Critical Z value, ideally it would vary, but seldomly, very seldom, in very seldom cases. Like for example, sample size to, for example, let's take an example of, as I said, square root of n. Remember, one of the formula to calculate the sample size, square root of n. Let's say if I have 100 pieces, so square root of n is equal to 10. Okay, but because of some reason, I cannot take 10 samples. I only have 5 samples. So I will not be even 95% confident. Then I can lower my confidence level. I can lower from 90% or 80% like that. वो कर सकते हैं. Okay, but generally we don't do that. All right, we consider that at 95%. Clear? Now, let's take a practical case. Everybody has noted down the formula, no? Because we are going to use this formula. Pull out your calculator. We will manually calculate today. Couple of examples. Everybody with me? Just give me yes. Super. चलो प्रैक्टिकल एक बार करके देखते हैं. ओके, मेरे पास बहुत सारे एग्जांपल है. मैं फर्स्ट, हाउ मेनी ऑफ यू आर फ्रॉम फार्मा? How many of you are from pharma? Just give me in the chat box. Pharma. All right. Okay, a lot of people. Huh? I thought कोई नहीं होगा. Okay, you guys are there. All right, fantastic. चलो, so एक pharma का example लेते हैं. Okay, let's say now you need to find out. There is a batch they have calculated. So I'm just noting down some numbers here. There is a batch they have calculated. They have taken. So we have that tablets like 500 mg or 100 mg kind of thing. That is the API content, which is the drug content in that, right? So they took that batch. So number of sample is equal to 30. Okay, make a note of this. The average X bar is found to be 498 mg. All right. Standard deviation, which is sigma. Sigma is 5 mg is the sigma, correct? And what else? And Z you all know, right? Z is nothing but simple. So Z value is 1.97, which is a fixed value. So X bar you know, Z you know, sigma you know, N you know, right? So can you just calculate the CI? Can you just calculate the CI? Confidence interval का formula है, डाल दो और मुझे आंसर दे दो फटाफट. चलो, formula is in front of you. X bar plus minus Z into in bracket standard deviation divided by square root of n. I have given you all the values. Now you give me the answer. Then I'll explain you. Now the specification limit is 500 plus minus 5 mg. Okay, plus minus 5 mg is a specification limit. Or you can say 1%, right? This is assay, right? If I'm not mistaken, you guys can confirm this. This is assay, right? We are talking about. So 500 plus minus 5 mg is the specification limit. So can you calculate the CI for this batch? And give me the answer. Everybody calculate it. Huh? एक बार करके देखो first time, because then your concept will become clear. Once you calculate it manually, then your concept will become clear. Anyways, we have the software, our master software with us anytime, always. So Don't have to worry about it. But our formulae, our the background formula should be very clear in our mind. You don't have to remember it, but at least you should be aware about it. Yeah. Can you just have the numbers? Very good. Super. Amazing. So let me. Okay, so it is for 496. So let me write down here. So the range is coming 496.222, is it? Or 21, whatever it is. And then 499.78. Everybody got this? Just give me yes. Very good. Very good. Very nice. Everybody got it? Huh? Very nice. So look. So now let me draw this. Let me draw this. Let me see how many of you understood this. Okay. Let me draw it in white so that you guys can understand. This is my target 500. My lower specification limit is 495. My upper specification limit is 505. And let me draw this. So my current process is somewhere here, 496 to 499. Are you understanding? Just give me yes in the chat box. Everybody with me? Averaging around 498. Everybody got it? Now answer this question. Will you accept or reject this batch? A for accept, R for reject. Everybody, will you accept or reject this batch? Why we are accepting this? Very good. Super. Amazing. Even the range, understand this. See, 498 is always in the range, but we have calculated the estimate. The variation estimate also is falling within the range, and that's why we are accepting it. Are you understanding? How important is this? Imagine we would have come, to this. Okay. At this level, the range would have. So this requires resampling. Okay. Most of the cases, these people would have resampled it. If it has gone, some range would have gone below the lower specification limit, then they would have taken the resample. Okay, they would have kept this batch on hold. They would have taken the resample. Again, it depends on the company to company, their organization strategy. Okay, but at this point in time, the current scenario, you can accept it, but your process, your API content has shifted on the lower side. So you have to take a quick action and take it to the center. From 498, you need to make a shift towards the 500 mg. Are you understanding? So ideally, your process should be like this, should be in the center and should be like this. Are you understanding? So right now, exactly, it's a lesser CPK value. Very good. Fantastic, Giriji. Amazing. So right now your process has shifted. Even though the range is falling within the specification limit, the confidence interval range, but still the correction is required. Everybody's clear about it? Just give me yes in the chat box. Everybody got this scenario clear here? confidence interval ka. So henceforth, do not just check the 1 point. See, mean is only 1 point, right? While taking the decision, check this range as well. That will also give us the some kind of direction. Understand this? Clear here? Because this confidence interval is taking care of the mean as well as the standard deviation as well. So both parameters are being taken care of here. So better not to take decision on only 1 point, which is the mean. Take the decision on mean as well as the CI, confidence interval. And then you can take the decision on this. Let me give you another example. There are multiple examples given. Okay. Let's say one company, which is a retail chain company. Okay. They have, now this is a scenario. Everybody read the scenario here. And company's satisfaction score, which is CSR standard, is 4 out of 5. Okay. Can you give me the confidence interval rating for this? A retail chain wants to evaluate customer satisfaction with the in-store shopping experience. They have surveyed 200 customers, okay, with satisfaction scale of 1 to 5. Okay, 1 is the poorest and 5 is the highest. Okay, the sample mean is score is 4.2, standard deviation 0.5. So we have 200n, mean x bar is 4.2 and standard deviation is 0.5, and the z value we all know 1.96, right? Z score is constant, which is 1.96. Can you just calculate a CI quickly? And the customer satisfaction rating standard is 4. Their standard is 4. Now tell me whether they need some kind of improvement in their customer satisfaction processes. Type it in the chat box. Calculate it and give me. Formula याद है सबको? CI formula is x bar plus minus z into standard deviation into square root of n. So put your values. X bar is 4.2 plus minus 1.96 into 0.5 divided by square root of 200. Yeah, what is that? 4.13. Everybody got the same answer? 4.13 and 4.26. (4.13 to 4.26). Everybody got the same answer? Just give me yes. Now, so will you continue the same strategy for customer satisfaction, or will you change it? Let's type K for keeping the same, K for keeping the same, K for keeping, and C for change. Type in the chat box. The standard is 4. Are we doing well? See the lower range and higher range. K for keeping the same process standards, and C for change. Keep the same, right? Very good. Because we are doing very well as far as the score, average, as well as standard deviation is concerned. Both are doing well. So better than expected. So we can continue whatever we are doing. We should not make any changes. Ideally. Correct? Very good. Very good. So there are some other examples. Average delivery time in e-commerce. An e-commerce company wants to estimate average delivery time of its order. A random data sample of 40 orders shown, okay, with average delivery time 2.8 days, with standard deviation of 0.6 days, with 95% CI. So they calculate the range, which is coming to 2.61 to 2.99. Okay. Now, the business decision is if the upper limit exceeds the target of 3 days, the company may consider the logistic process improvement, because even the higher range is 2.99, where their target is 3. It is not exceeding that limit. So right now, again, they don't have to consider any kind of changes in the stable process. So let them continue with this, okay? Because they are doing well within the range of this. Okay, this way you can calculate. So rather than taking decision on only one point, you can take the decision on the estimate. Okay. A nutritionist wants to estimate the average daily calorie intake for the college students. Okay. Now, nowadays, the obesity generally is a very big concern in the Western countries. So even in India also nowadays that is coming up. So they have taken 100 samples and 100 students, and the mean intake is 2,300 calories. Okay, standard deviation with 200 calories. So with 95% confidence interval, they check that 2,260 to 2,340 calories is there. And according to the nutritionist, it should never exceed 2,200 mark. But because, what you can say, in that college canteen or whatever is that mess, whatever is there, whatever intake they are taking, the average intake is going much beyond the guidelines, which is 2,200. So the interventions are suggested. So they need to check a very tight check on the calorie intake. So they have to reduce the low calorie diet, low calorie food in the canteen. So this way you can take the decision in your practice. That's why 95% confidence interval is used in practical life. Are you clear, everybody? Just give me yes in the chat box. समझ में आ गया? With these examples, practical examples, with a formula. Super clear? Very good. And Minitab has by default setting of calculating it, so you don't have to do any supernatural change in your practice. Just select the data, put it in the Minitab software. It will give you the 95% confidence interval, and then you can take the decision accordingly. Okay. So this was basically taken because I think a couple of weeks back, when we were discussing about the basic statistics with Minitab, somebody asked about 95% confidence, and I committed that I will take a session on this 95% confidence, and we'll take up some practical cases and we'll decode the formula as well. That's what we have done today. Okay. Super. Thank you very much. So tomorrow we have our yellow belt session in the morning, right? So if you want to send your team, send your colleagues, send your team members, you can send them. And if they join, you'll get the referral bonus of 40%. Okay. Standard deviation is a sample or of the population. Standard deviation is of the sample. So everything is taken for the sample. Sample standard deviation, sample n number of data points, sample mean, everything for the sample. Yeah. Because population, we may not be aware of it. All right. Yeah. So all the new members, anything about Minitab or anything about any query rather than this, you can always send a message on our WhatsApp number. Okay. So Sunday is tomorrow, right? So tomorrow we have a yellow belt session. So you can also join if you wish. And you can just send a message on our WhatsApp number, mentor number. They will give you all the details. You can, there are more case studies which are there in the PPT. I'll be sharing the PPT. There are more case studies as well. You can just check out. Okay. Sunday, next Sunday. Every Sunday it will be. Every Sunday. It will happen every Sunday. So if you miss tomorrow, you can always connect on next Sunday. Yeah. All right. So thank you very much. And I hope this was, this was useful. Did you enjoy the today's session? Some new concept got clear? Yes? Fantastic. Amazing. Very good. Very good. Super. Thank you very much. Thank you very much. Okay, so keep learning, keep growing. Please spend some time in our LMS system, course number 1, course number 2. Okay, take the notes, ask the question to the mentors, and make maximum out of this entire ecosystem which has been built for you. Okay, super. Thank you very much. This is Dhiresh Patil signing off. We will connect again on Monday with the same enthusiasm with a new topic. Till the time, keep learning.